Okay, hi. I just wanted you to look at the playing cards again. I want to do one more card example since I made the picture, and they're good examples. And I think this one's particularly easy. That you don't need to understand anything about any particular game really. Um, so the problem's going to be, I'll write it down in a second, but just so that you can look at this while I talk. You're going to deal to four players all 52 cards. So each player will get 13 cards. You're just going to deal them out randomly, and as if you were playing bridge, for example. Um, and then we want to know what's the probability one player gets all 13 of the spades. Um, and that's part A. And then part B is what's the probability each player gets a different ace. Not any particular ace, but each player has one ace exactly. So those are the two questions we want to answer with that. Okay, so um, let me see about putting this here. Yep. Okay, so example 3. I'll call this 3 now. So deal all 52 cards to 4 players, 13 each. Let E be the event. One player gets all spades. Okay, and let F equal the event. Each player gets exactly one ace. Okay. All right. Again, we're assuming random shuffling and dealing. So any set of 13 cards has exactly the same probability to land in any player's hand. Okay. This is a point really that needs to be brought out, but usually not a lot of fuss made over this. So in that case, let's find P of E then. So solution for P of E is, let's see. Well, let's just fix one player. Say we have player 1. Well, there's only one way to get all spades. That's the lucky thing about this question. You only have to worry, it's a unique hand really. So this is just 1 over the size of the sample space, right? So yes. So note, first of all, equally likely outcomes. Every deal is equally likely. So let's have let EI equal the event player I gets all spades, because I want to just know of any of the 4 players. Okay, then P of E is equal to P of the union 1 to 4 EI, but these are mutually exclusive, so that's equal to the sum. So this is just sum 1 to 4 PEI, which is just equal to 4 PE1, any of them. But the probability, say the first player gets all spades, there's only 1 out of the total. So this is just 1 over 52 choose 13, right? 52 of the hands, yes, 52 choose 13. Because, let's see, does that make sense? Yes. If I look at S in this case, so in this case, S is the sample space of hands and that player 1 could get, and and E1 is the event gets all spades. So in this case, so yeah, maybe that's a little unclear, but P of E, let's write P of E1 is equal to, just, I want to reassure you, this is still true, where now, E1 is all spades for player one, and S all possible 13 card hands. Okay, so I wrote 1, so it should be 1 over that times 4, right? Because there's 4. All right, that's pretty small. We don't have to do that one, I don't think. But you can see that's going to be pretty small, right? Because if we do this, then P of E, I won't do it out all the way, but just to see, is going to be 13 factorial times 4 over 52 times 51, dot, 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 all the way down to 40. Okay, so this is going to dominate the denominator down here, so it's going to be pretty small. Okay, for the other part, okay, so for the other part, for P of F, what do we have to realize now? Probably each player gets 1 card. So now we got to consider all the hands. Okay, so for P of F, we have to consider all the hands that are possible. So S is all possible groupings of 52 cards into 4 groups of 13. Right? Because I need to consider all the outcomes. I think I need to do it this way, where I have, so that's the first player, and then this is the second player. I'm going to run out of room. This is the third player, and this is the fourth player. And I need to consider all the ways that the 52 cards can be here, 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 and here, because I got to check if there's one ace here, one ace here, one ace here, one ace here. So the S is going to be, so S, size of S here, it's really a different S in a way than up there, is going to be 52. It's a multinomial distribution, 13, 13, 13, 13. That's just 52 factorial divided by 13 factorial to the 4th power, right? I'm dividing out the order in here because I don't really care about what order they are when I shuffle them. I mean, everybody moves their cards around anyway, right? That doesn't have anything to do with it. All right, so now the trick is to find the size of F. So what's the size of all possible distributions of the cards into hands, that where the order within the hand doesn't matter, such that everybody gets an ace? Well, the simplest thing, I think, is to just realize that, so for F, take out the 4 aces. And see, there are, let's see, 4 are gone, so 48, 12, 12, 12, 12 possible groupings of the remaining cards to 4 players. So that's 48 factorial divided by 12 factorial to the 4th. If now, yeah, so if, let's see, if, what the hell was I going to say? Yeah, so I think that's it. The only thing is the aces could be distributed differently amongst the 4 players. I could have any of the 4 factorial possible assignments of ace to players. So I actually have to multiply this by 4. It's funny because this you don't have to multiply by 4. That's really all taken care of in here. This gives you all the distinct possible distributions of these as they are unique. This comes from listing them all out and then factoring out the factorials in the bottom. So also because there are 4 factorial assignments of ace suit to player, we have that F is equal to 4 factorial times 48, 12, 12, 12, 12. Okay. So in conclusion, let's see, I don't want to make this too long. So PF is equal to, say 4 factorial, 48 factorial, over, and down here I had the 52 factorial, and down here I have 12 factorial cubed, and up here I had the 13 factorial cubed. I don't think it will be too bad. We can do some cleanup here. It's not too bad because so I get 24 times 13 to the 4th over, that's gone, and down here I have 52, 51, 50, 49. We could do a little more cleanup here, right? It's actually, you can clean this up. So let's see, I get maybe a little more. Sorry, I can't resist. 8 times 13 cubed. I took a 3 out and a 13 out, so I have 4 times 17 times 50 times 49. I don't see any more 13s. I could take an 8 out now, or 4 out, and write this as 2, 13 cubed over 17 times 50 times 49. I think that's it for me. So I think it's about a 1/10, okay? So hopefully you should check and make sure it makes sense. You don't want it certainly to be bigger, but it looks like we're safe from it being bigger, right? Since 2 times 13 is less than 50, and 13 squared is less than 17 times 49. This looks like at least a reasonable answer. Okay, one more.